Welcome. In this video, we are told that h is equal to the composition of g and f divided by f, and we want to find the derivative of h evaluated at 0. And we're given this graph here. And this graph shows us what g of x is and what f of x is. So we will be applying the chain rule, and on top of that, we'll be applying the quotient rule. So let's get started. H prime of x is equal to the derivative of the numerator, so that is the derivative of g of f of x, times the denominator minus the numerator times the derivative of the denominator and this entire quantity divided by the denominator squared. Let's clean this up a bit. The one derivative involving the chain rule is this one. I'm going to do that in blue on the side here. So that is the derivative of g of f of x is equal to the derivative of g evaluated at f of x times the derivative of f of x. And that's going to go here in my next step. And before I continue, I want to make it very clear, this is just this derivative here. So I still need to multiply by an f of x. Not to be confused with f prime. I will not have a squared here. I have a derivative of f multiplied by f itself. Next, we're going to subtract g evaluated at f of x times the derivative of f of x, and that's just f prime. And again, this entire quantity divided by f of x quantity squared. Okay, now that that is done, what is h prime of 1? Excuse me. All right, now that that is done, what is h prime of 0? Well, we have to start filling in zeros for every x here. So there it is. I have rewritten the first derivative of h, and I've rewritten in a manner so that we are evaluating the first derivative of h at 0. So there's a few quantities we need to find first. Let's look at all the quantities that are not a composition of functions. That is the derivative of f at 0 and f evaluated at 0. I'm going to begin with f evaluated at 0. Since that's easier to find, it looks like this pointy arrowhead here. And when x is 0, f is 2. Now, if you recall, the derivative of a function is the slope of its tangent line at this point, in this case 0. So what is the slope of the line tangent to this curve at 0? Well, if you notice, the slope is constant. That is, we are going a rise of 3 over a run of 1 pretty regularly. You notice these 4 points, here, 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 and here, all intersect our grid lines really neatly. You could take a moment and use the slope formula, that is the change in y over the change in x, with any of these 4 points. Or you could just notice that the rise is 3 and the run is 1, so the first derivative of f everywhere is just, well, excuse me, not everywhere, between -1 and 2, not including the endpoints, is just 3. Okay, let's continue rewriting then. Now, since I have an f evaluated at 0 here, and that's 2, I'm going to write a 2. Then, instead of writing the first derivative of f at 0, I'll just write 3. And again, another 2. take a moment, pause your video, and see if you can complete the rest of this. That is, fill in the rest of these blanks. You should have obtained this right here, that is, this we did together, and you should have minus g evaluated at 2 times 3, all divided by 2 squared. So now we need two more quantities, that is, we need g evaluated at 2, and we need the first derivative of g evaluated at 2. The graph of g is a little more interesting. There's this flat spot, this parabolic looking spot, and then this linear spot. But at 2, we are right on this parabola. So get a ruler out and place it as close as you can here, as if this ruler was a roller coaster that is going along this roller coaster track. That is, the track is g of x. So as you can see here, I sketched this line that is tangent to this function g at x equals 2. And the slope is fairly straightforward. It has a rise of 2 and a run of 1. So this tells me that g prime of 2 is equal to 2. And then, of course, in my haste to draw this tangent line and figure out the derivative, I forgot to evaluate g at 2. So the function g evaluated at 2, that is, we would just look at the function value of this orange graph at x equals 2, is just 3. So I can rewrite this further. So this is just 2 times 3 times 2 minus 3 times 3 divided by 2 squared. And this simplifies to 12 minus 9 over 4, or just 3/4. I hope this video has been helpful.